Good afternoon or evening, wherever you are. Welcome to another session of HashiCorp User Group Sydney. And I'm joined once again by Hamid. Thank you very much for joining us. Would you like to give a quick intro on yourself for people that have not seen you talk in the first round a couple of weeks ago?
Yeah, thank you. Hello, everybody. My name is Hamid. I've been working as a DevOps engineer for more than 4 years. I started my career as a Linux sysadmin, and after a while, I switched to DevOps. Today we're going to talk about Terraform workflow, and I hope you liked it.
Great. All right, so let's begin. Take it away, Hamid.
Yeah. Okay, let's share my screen. Okay, as I mentioned before, today we are going to speak about chapter 6 of Terraform exam review about navigate Terraform workflow. Uh, mm, we are somehow familiar with Terraform workflow so far, but today we are going to get deeper into it. Let's go ahead with the first step, the core Terraform workflow. And just before get started with this step, please pay attention to these. Um, Generally, in Terraform, we use Terraform in three ways. First, as an individual user. Second, a single team. And third, an entire organization at a scale. Uh, we use these three sections and three concepts in different steps and different sections as well. What's the core Terraform workflow? The core Terraform workflow has three steps, uh, let's, yeah, has three steps, three famous steps, I can say. The first,
Super
write.
famous.
Yes, because when we are coding and we are writing this configuration file, and for execute this configuration, we always use these three famous steps. First, write. Writing configuration files, I mean .tf files, and after that, plan for previewing changing changes before execute in the infrastructure, and finally apply provision real infrastructure. Let's check the right step. As you can see, uh, in
Before we
right
go there,
step,
actually, one
yes.
one important thing that is consistent, this whole write, plan, and apply step, it doesn't matter whether you're doing it on GCP, AWS, or anything else, you're still going through the exact same procedure. So it's almost like something that you need to hammer in and build it into your muscle memory when you're working Terraform. It's always write, plan, apply, write, plan, apply. There's no deviation regardless of what you're working on. So
Yeah, of
absolute golden
course.
rule.
Exactly. And that's the very important point. In these steps and write, plan, and apply, we don't pay attention exactly what cloud platform, because it's a basic uh, steps for prepare Terraform and using Terraform. In first step, write, as I mentioned before, and also for as an individual user, not as an not for using as a team or in organization. We write Terraform configuration just like coding just like you write code, and it's very common uh, practice to work in a version control and work with repositories. After writing code, we in next step for plan, when we make sure about the code and its syntax, and now we can commit it and push in the repository. And finally, after this step and preview the changes, in apply step, after one last check, uh, and we know we are ready for uh, implement that changes, so we apply it, and uh, uh, Terraform prepare our desired infrastructure. And also, in as an individual user, we use Git repository, and we push all our codes in that repository.
It's very
This was,
important using Git. It's like
yes,
if you as a developer are not using Git or any form of version control, you're gonna get
yes, of course. But when we talk about working as a team, uh, in working as a team, when multiple people are collaborating on Terraform configuration, of course, new steps must be added in these Terraform workflow. For example, in write step, we work on in branches, Git branches. Work in Git branches enables team members to resolve mutually incompatible infrastructure changes using their normal merge conflict workflow. And another thing that's very important, and if you work in a company, of course you faced it, uh, as the team and the infrastructure grows uh, in a while. So there are lots of sensitive variable, and that's required when you want run Terraform plan and check. And as I said, they are sensitive variable. For example, API keys, SSL cert pairs, etc. For resolving this challenge, uh, it's common for teams to migrate to a model in which Terraform operations are executed in a shared uh, continuous integration CI environment. And we can use uh, lots of tools in this environment. For example, Circle CI, GitHub Action, GitLab, Jenkins, etc. for running Terraform in automation. That's very interesting.
do you have
Uh,
any experience in doing these GitHub Actions type thing where you passing in sensitive variables into a plan?
Yes, actually, I don't have any experience in GitHub Action,
Mhm.
but in my current company that I work now, they use GitLab, and it contains, I think, three or four steps. First, check syntax and Terraform validate. In fact, they design for running Terraform validate on our configuration files and on our code. And after that, Terraform plan, and finally, it's just manually we should confirm it. not as
Have
a
you? How
automation.
did you like
Automation. Yes.
set these sensitive variables in Terraform plan in a CI pipeline like you described? Do you have any examples of how that actually works?
I think in Terraform,
Hmm.
when we want to pass some sensitive
Hmm.
variables, we use a file, for example. It's the best, I think, it's best practice, tfvars, and
Yeah,
they put this file in the these variables in this file, and most of the sensitive variables we couldn't we can't see.
yeah.
For example,
Obviously, you
yeah,
shouldn't put those in there. Yeah,
yes,
correct.
yes, GitLab admin use these kind of certificate and these kind of variables in that file, and we can't see it, or and of course in the log we can find it.
One
Yeah.
of those examples that we have done before in some of the previous videos was with some of these sensitive variables because there are ways for you to pass in a value into Terraform without needing to actually hard code it into your file. And let's just say if you had a variable called var.password, for example, obviously you're not going to put password equals ABC123 in your TFVARs. But what you can do in a CI pipeline is use environmental variables where in the pipeline you could just specify one of the lines that go tf underscore var underscore, then the name of that variable, so password, equals whatever value you actually do. And because this is in your CI pipeline, you could always insert the sensitive variables, the values of it, into the pipeline without developers ever having access to it. Say, for example, in GitHub, you can pass these in as repo secrets. And even if this repo is shared among multiple people, they can't actually, click the button to reveal the password. It's just saved in there. It's accessible in the pipeline, but it's secure. So that's one of the ways that I've done sensitive values. It can get a bit cumbersome once you have too many of them. If you say you have 20 passwords that you're supposed to be storing, it does get a bit messy in there. But when you do get to that level, you can search for other methods of secret management like HashiCorp Vault, which we were planning to do after this whole Terraform talks wrap up. But yeah, that's one particular method that I have had quite a bit of experience with, passing sensitive values into parameters.
Yeah, of course, exactly. That's very good way for prevent uh, and of course prevent sensitive data, and of course it's more secure in pipeline, which is very important. Yes, let's go ahead. The next step, I mean, plan a step, but for working as a team. For teams collaborating on infrastructure Terraforms plan output creates an opportunity for team members to review each other's work. You know, uh, when we create, when we use Git branches, and as a team member, and all team members work branches, finally after these branches, they use the natural place for these reviews to occur is alongside pull requests within version control. For example, if a if a team notices a certain change could result in service disruption, they may decide to delay merging pull request until they can schedule a maintenance window. That's very important and useful way using pull request for as a kind of code review. And the next step, apply. Once a pull request has been uh, approved and merged, it's important for the team to review the final concrete plan that's run against the shared team and shared team branch and the latest version of the state file. Uh, that's very common these days in a team when we use Git branches, pull requests, and CI/CD for running Terraform in automation.
And that's
Uh,
the best part, isn't it? Because this whole Terraform thing, you're actually just doing typical best practice developer work anyway, doing stuff in branches, not ever, committing directly to the main branch, and only running the pipeline on any commits or any changes to the main branch itself upon merging pull requests. So if you follow your standard developer best practice methodologies, Terraform doesn't hinder you or affect how your workflow is in any way. You just do it, and it would work just nicely if your pipeline is set up correctly.
Yes, of course. This way helps the team and beyond the team, the organization, for focus on the code and focus on the uh, uh, infrastructure as code that helps them for using it as a, for example, disaster recovery plan when something uh, happened wrong, and when they want to roll back in the previous stage, they can do it very soon and very easy. Uh,
Yeah, just revert
yeah.
one commit and rerun it, isn't it?
Yes, of course. Yes, of
I
course.
mean, you actually mentioned Atlantis earlier in your talk. So Atlantis is actually one of the really cool platforms that we've seen. I've personally not actually used it before, but if you look at the Atlantis website and the demos that they have, it looks really cool. So how it works is you put a pull request through. Is that right? I mean, if you put a pull request through, it will run and actually do a plan and say this pull request is going to create, I don't know, 10 new resources or whatever. So that's an easy way for the developer that's reviewing the pull request to firstly validate is your syntax correct. There's no breaking changes in there, and whether or not the impact is desired. So with Atlantis, you get an immediate feedback on that rather than merging it to main, and once it's in main and it starts deploying, you go, ah, crap, I did not mean to delete that database.
Yes, of course. Actually, I found it so interesting to me, Atlantis, and also another tools, TFSec, uh, for CI/CD pipelines.
Yeah,
But
TFX cool.
yes, TFSec. Uh, but up to now, unfortunately, I don't have any experience uh, for working with these tools, and of course, I have planned for working with these tools in the near future. Yes, of course, that's very good.
Clarification: Atlantis, TFSec, these things, they are not related to your exam. It's just really fun stuff that you should look into if you're doing Terraform, but you're not going to get quizzed on that.
Yes, actually. Okay,
You
and
forgot OPA. OPA is the really cool one. OPA is
yeah,
Open Policy Agent.
yes, and I found these tools when we combine these tools together. That's a very good result. That's we can have a very uh, very advanced automation when we use TFSec, OPA, and Atlantis. Maybe just using one these kind of tools, it doesn't make sense. But when we use it as a part of pipeline and CI/CD design, that's very good combination. Yeah. Okay. In the
Sorry,
next,
I totally hijacked your train of thought. You were going along in a straight line and we just went, whoop.
Yeah. Uh, it's a good common use for using the core workflow enhanced by Terraform Cloud. We talked about the positive point for using Terraform as a working as a team. And we should know Terraform Cloud in Terraform Cloud is designed. It's designed to support and enhance the core Terraform workflow for any collaborating, and it covers all these steps that we talked about it. Uh, yeah, we can use Terraform Cloud. The next step and the next subject that we are going to speak about it, it's init, Terraform init. In Terraform init, as we used a lot before, uh, this command is used to initialize a working directory containing Terraform configuration files. This command is always safe, and so we can run multiple times, and it will never delete our existing configuration or a state file. But let's check it deeper and check its options here. Uh, for example, when we use Terraform init with these options, dash from module source, uh, here we can copy, actually, we can copy the a module that we use it in the module as a source argument, and it can be run against any empty directory with the dash from module equal module source option, in which case the given module will be copied into the target directory. And
Think of that
uh,
just like git clone. It basically, from module, it just takes a module from Terraform's public registry and clones it into your folder. That way you can start tweaking with it, making changes that, whatever tweaks are necessary to go with your particular workflow that may not be out of the box behavior from the module's original author. So it's quite a powerful, handy tool.
Yes, of course. Uh, it's powerful, and based on this document, it says uh, this step and this spatial mode of operation support two use cases. One, when we want to get a configuration from version control, and another one, if the source refers to an example configuration, it can be copied into a local directory. And finally, we should know for routine use, it is recommended to check out configuration from version control separately using the version control system's own commands. And we can use their options as well. Uh, just before get started, next subject, backend initialization. Let's check this concept, backend. And what is backend? Backend, as I found it, backend define where Terraform's state snapshots are stored. And by default, Terraform use local backend. When you run Terraform init in a directory, after that you can see some files such as terraform.state and terraform.state backup, and these kind of file as a snapshot. Uh, but backend, we can use backend also as a remote backend, and we can use remote backend for restoring Terraform and snapshots. So as a result, we have two types of backend: local backend and remote backend. And by default, Terraform use local backend. In backend initialization by Terraform
Sorry,
init,
Hamid.
yeah.
Before we go into that, could you explain what are the benefits of using a remote backend against a local backend? Assuming we're working in a team environment, not like a
Yes,
single dev. Yeah.
yes, of course. When we use a remote backend, our state snapshot and our state file, which is very important for us because, as we talked in the next previous step, the important, I can say, the most important thing in Terraform after coding, after planning, after applying, is the state of our Terraform. Because when we want to, for example, roll back, or we want to change something, it's very important file, and this matter. So when we use a remote backend, we uh, keep our state file and our state file in a remote uh, uh, repository, I can say, as for example, as a repository. And it's very good when we work as a team. Uh, all of us and all team members, work on a code, and when they want to apply or check its plan, uh, they have one state file. And where is it? In the remote backend. Uh, uh, and I think it's more safe, because if
Keeps it consistent, right?
yes,
Because everyone has that one source of truth instead of if you saved it in your folder, who knows, is it Ben's repo that has the latest state file or Hamid's repo? So when two devs do the apply at the same time, you get out of sync, and Terraform does not like being out of sync.
yeah, exactly. And yeah, that's it. I think, and I think we have to use remote backend in organization. Am I right, Ben?
Correct. You'd almost never do local state except when you're doing a tiny self-development testing type scenario. Otherwise, there's almost no scenarios where local is better than remote.
Okay. Yes, of course. In By this explanation, in a backend initialization, we can use dash migrate state option. This option will attempt to copy existing state to the new backend. And also we can use dash reconfigure option. This option disregards any existing configuration, uh, preventing a migration of any existing state. And also, we can use dash backend config option. This option can be used for partial backend configuration in a situation where the backend settings are dynamic or sensitive, and so cannot be statically specified uh, in the configuration file. Let's check one of these. For example, in this file, we have under the name config.console.tf backend, we have backend config, and we use in main.tf this block backend and we can use this kind of configuration. Uh, there are lots of options actually for this command, Terraform init. And we can use dash upgrade. When we use dash upgrade, it just update uh, all modules to the latest available source code. When we use module, we know it's very important thing and it's required in module, the first argument we should pass source, where, uh, from where, for example, from the version control or from your local. And also, we can use Terraform init for installing plugins. Uh, uh, we can
Sorry,
install,
just
yeah,
one thing on the upgrade. That you're absolutely right with the modules thing. One other thing that upgrade also does is it upgrades your provider. So um, when you first run Terraform init, you're downloading a version of the provider, whether it's AWS or Azure, whichever it is. You'll see that it has version, say, 2.1.0 or something.
yeah, yes,
And that gets saved. You'll see a file called tf.log.hcl, something along those lines. There's a log file, and that actually stores the version of your provider. Now, in most scenarios, Terraform wouldn't upgrade the provider once it's downloaded it once, unless you specifically say to upgrade. When would you use the upgrade? Because providers are updated every 2 weeks or every week or so. You could see a new feature that gets inserted, that gets created into that new provider, and that's when you use upgrade to bump up the number of your provider. And that's something that actually happens quite often, that you would just upgrade the provider. Sorry, Hamid, go
yes.
ahead.
Yeah, of course. So, as you said now, I think it's more useful and option, and we use it a lot. Am I right? Dash upgrade because cloud update every week, and maybe we should use it more, more than other options.
Typically, yeah, I only do the upgrade when there's a specific feature I need, because there have been a few scenarios where I've upgraded the provider and all of a sudden it's expecting a new parameter, say just using S3 bucket as an example. All of a sudden a new feature is no longer an optional parameter, and after I upgrade, the pipeline breaks because I was expecting parameter A, you did not give me that parameter. So use upgrade when you use upgrade, make sure that it's not an auto run. You need someone to actually monitor and make sure nothing's broken. It's good to use, but I wouldn't leave it completely automated when you do an upgrade run. You still need to debug it a bit.
Yeah. Thank you. Okay. We can use, as I said, we can use Terraform init for installing plugin, and also we can use some other options about plugin. For example, uh, plugin dir path and force plugin installation to read plugins only from the specified directory, or dash get plugin equal false, skip plugin installation. Uh, this was about Terraform init. The next topic we are going to speak about it. It's about uh, Terraform validate. Okay, Terraform validate. We I think it's a uh, very useful
Very
command.
handy, this one. You
Yes,
just
and very
keep typing
handy.
it as you go.
Yes, of course. The Terraform validate command, as we know, based on its name, validates the configuration files in a directory, referring only to the configuration and not accessing any remote services, such as remote state, provider, APIs, etc. And we can use it locally, and it doesn't need connection to cloud provider. Uh, Validate runs checks that verify whether a configuration is as a syntactically valid and internally consistent. Uh, it's a very safe command, and we can run this command a lot and multiple time. And also we use this command in uh, as a post as a pre-step in CI/CD pipelines. And validation, it's important for running validation. Validation requires an initialized working directory. We talked about it now just before. For initialize a working directory, we should run Terraform init. And so when we want to run Terraform validate before it, we should run Terraform init. And yeah,
In it, almost it's like the step that you do at at the very beginning of the project. All it does is it pulls down all the providers, and all validate actually does is it just checks your syntax, like what Hamid said. So raise your hand if you had your code broken because you missed the curly braces of parentheses. Breaks all the time. So Terraform validate exactly helps you. You just type validate, it straight up gives you a red line saying, "Nah, your code is not valid at line 72 or whatever. Expected closing bracket got some other character." So just run validate almost every time right before you save. Well, right after you save, you hit validate. It'll tell you was your file correct or not. It's almost like you should run it before every commit because you don't want to commit dodgy code. So validate it. If it says success at the bottom, then do the commit.
yes, exactly. It's very useful and handy command. And as I said, we need initialized working directory. Uh, Here we can see this Terraform init with the this option dash backend equals false. To initialize a working directory for validation without accessing any configured backend, we can use Terraform init with this option dash backend equal false, and after that we can run Terraform uh, validate. I think we can run this command in a empty directory Terraform init dash backend equal false, and after that we can run Terraform validate. Uh, Terraform validate, we can use dash JSON for giving JSON output format, and we can check, for example, this is a kind of these output for validate command. It's an example. As you can see, there are lots of attributes in this output JSON output, and for example, valid attribute summarizes the overall validation result, error count, warning count, diagnostics, severity, summary, etc. Uh, I think these output most of the time maybe it's very useful in designing CI/CD because as I think, I don't know. Please correct me, Ben, if I'm
You've seen
mistaken.
more than I've
Yeah,
ever seen. I've never actually used a JSON output before because
yes,
I just
because
see error and I fix it. I was like, oh shit, I didn't even know you could do
yes,
JSON. That's new.
yes, of course. Because for usually, Using we use Terraform validate without any other options, and we can see the result. But for dash output, JSON dash output, maybe uh, in CI/CD pipelines they used. I don't know.
I
We
don't
can
think that
work.
ever really gets used much.
Yes, of course.
Actually, before we go too far, we've got a question from Pavan. So he's asked, what changes happen when you run Terraform init more than once?
Changes that make you want to run. It doesn't happen something strange. Uh, we can run multiple time Terraform init, and it's very common. Uh, uh, it based on previous execution that we run and that we ran, all plugins and all requirements downloaded from um, provider, and you already have it in your local directory. So when you run Terraform init multiple time, it doesn't happen something new, except you use some options. For example, dash reconfigure or dash upgrade. By these options, yeah, you can force this command to do something new.
Yeah, to
Uh,
actually have any impact. But
yes,
Pavan, if in your question, if we specifically only ran Terraform init, no dash, no flags at the end, you run it 10 times, nothing's going to happen.
yes, exactly.
And the only time things happen is like the flags that Hamid said, or if you actually change your backend. So if you can change your backend configs from, say, your remote storage in from one S3 bucket to another, from an Azure storage account to another, or even changing from a remote storage to a
Yeah,
local backend, that's when Terraform init would do something when you actually change the backend. Otherwise, running init, all it's going to do is pull the modules, and if the modules have updated, it will pull the latest module. But aside from that, nothing's going to change. And it's a very safe thing to type, just like validate. Just spam it
yes,
for the heck of it.
yeah, exactly. Okay, this was about Terraform validate. Let's go ahead with next command, Terraform plan. Terraform plan uh, as a second step in Terraform core flow. In Terraform plan command, this command creates an execution plan which lets us preview the changes before execute in real infrastructure. By default, uh, when Terraform creates a plan, it reads the current state of any already existing remote objects. It compares the current configuration to the prior state, and it proposes a set of change action that should. We can use, it's very common, especially in CI/CD pipeline. We can use the option dash out equal a file name to save the generated plan to a file on a disk. And after that, we run for applying, we will see this option in Terraform apply. Uh,
Why would you
and
use out?
yes.
Hamid, could you explain what's the benefits of using the out equals file against just regular Terraform plan?
Uh, Actually, I searched about it before. Why we use dash out equal file, especially in CI/CD
Hmm.
pipeline. But actually, I couldn't find any
Sure, no problem.
suitable answer. Yes,
I could give
please.
you what my understanding is on this. So, um, if you're running this locally as you're developing, as coding away, good practice is you run Terraform plan just to make sure that to see exactly what's going to happen as the change based on the change you do to the file. In this scenario, doing it locally, there's absolutely no benefit to using the dash out because you're not actually storing or using that file in any way. Um, Terraform plan is the equivalent of like a dry run in Docker. So when exactly you would use out is when you save that file and you run Terraform apply on that specific file. Because if you ran Terraform apply like now, and I didn't change the file, and I ran Terraform apply 5 minutes later or 10 minutes later, when another developer had made some changes to the file, I'm comparing my Terraform plan that was 5 minutes ago, and when I hit apply, those changes may no longer be in sync because someone had done some commits in between. So that is when you Terraform plan output a file. And even if a dev had done a whole bunch of stuff in between, when you apply, you're doing exactly what the plan had said it was going to do. That's when you would use out. And generally in a CI/CD pipeline type thing, you just save that output, that plan output. You can do all kinds of validations on that plan, on that file, that output file. What we mentioned before with OPA and TFSec, that's run against the output file. OPA will look at that file and say, all right, I've looked at this. You are adding 3 resources, deleting 1. And that's how it processes it. And that's basically what you would use the output file for.
Yeah, thank you. Thank you for your good explanation. Yeah, that's very useful. So, uh, and we have two types of planning modes for Terraform plan: destroy mode and a refresh only mode. We can use Terraform plan dash destroy as a destroy mode, and it creates a plan for destroy all remote objects that currently exist. If we use dash refresh dash only with a Terraform plan command, it creates a plan only to update Terraform state, not nothing else. And also we can use we can use these options in planning. For example, dash refresh equal false, disable the default behavior uh, for refreshing, or that's a very common option, dash var dash file. In which case, in this case, we pass uh, the, the file name of our variables that I mentioned before when we wanted to run uh, Terraform plan and we have sensitive input variables. We want to pass these input variables with these options. Dash, let's check, dash uh, var dash file. Yeah, here. Yes, we can use it. And most of the time using they use tfvars files. They use this kind of name. Also, we can use dash target equal address. This option use for just focus to specific resources. And we just use Terraform plan with dash target uh, for referring specific resources. And of course, at the end, dash out file name, which we talked about it. Uh, uh, and also we can use Terraform plan dash var with this kind of syntax. We can use Unix syntax, Unix style, or somehow PowerShell style, Windows command prompt with these two different. It is Unix style shell and it is Windows command prompt shell for passing variable to Terraform plan. Okay, let's go ahead. The next step, apply. After plan and check the preview that we want to run on infrastructure. Now we want to apply it. Another way to use Terraform apply is to pass as we talked about it just now, just before now, is to pass the file name to of a saved plan file we created before with Terraform plan -out, for example, plan file, and after that, for applying, we use Terraform apply with uh, this file. And also we can use Terraform apply for dash auto approve. It's very useful option for skipping confirmation prompt, especially for me when we want to when I want to work fast and for example, I write some Terraform code and I want to check it's correct or not. Somehow this kind of confirmation it's not very good. I use most of the time -auto -approve. And also we can use Terraform with -chdir for switching working directory for applying, and we can use it. Most of the time in automation, we use -input equal false, because in automation, mostly we don't want pass some variables as a interactive shell with interactive shell, and so we use Terraform apply or with this option -input equal false. Yes, this is the this was about Terraform apply. Also here we have plan options that kind of plan modes and plan option that we talked about it in Terraform plan command.
As an
Uh,
example, that dash target that Hamid was talking about, like you would any of the plan stuff that you were able to type before, you could always put it into apply as well. So one thing about the auto approve that you mentioned, Hamid, you can run Terraform apply -auto approve. That will skip that prompt that says this is a plan. Do you want to proceed? Yes or no. But if you ran a Terraform apply on an output, like a Terraform apply plan.tf plan, something to note, when you run it on a plan, it doesn't ask you for approval, it just does it. So the auto approve is not required when you're doing it on a plan file. That's it.
yeah, of course. Yeah, of course. When we use Terraform, yeah. It's
It
very
caught me out
cre-
once
it,
before when
it's
I didn't know that it automatically does it. I just typed Terraform apply and I gave the file name and it started deploying it right away. I was like, oh, did I want to do that?
yeah, it's a good tips. Thank you. I didn't know that. Yeah. Uh, okay. Let's go ahead with the next step. Terraform destroy.
Woo!
The easiest, the
Boof.
easiest com- command. Terraform destroy command is a convenient way to destroy all existing um, object and resources, and Terraform destroy is just a convenience alias for the following command: Terraform apply dash destroy. Uh, we can use it as a alias, and also as we talked about it, we can use Terraform plan dash destroy for creating a plan for destroying. Yeah, this was about
We
chapter,
call with a few
navigate
names for
Terraform
Terraform Destroy.
workflow.
It's like either the Terraform Sledgehammer or the Terraform Nuclear button. It just boof kills everything.
Yes. Uh, yeah, it was about this chapter, navigate Terraform workflow. I think extra of and these topics, I found Terraform automation, uh, running Terraform in automation, very interesting. And also, as you said, Ben, working with OPA, TF and Atlantis. That's very, I think, very interesting thing. We can work on it for learning new things, extra of this exam review. Yeah, it was a uh,
Sure.
my
Yeah.
presentation. If you want to add something, I hear.
No, that was great. Thank you very much for explaining through the whole Terraform workflow. And in a way, that this whole init plan apply thing, it's quite a basic thing, but there are actually a lot more than just literally typing Terraform init Terraform plan. It's quite useful to know all the extra things that you can pass behind, like plan dash out. That's one of the most common flags that you do. Var file is another thing that it's very common because you will be passing in values through the Terraform variables file, TFRs. Auto approve, again, very useful. What else is there that's quite handy? I think you've actually covered it all. That was a very good session, Hamid. Thank you
Yeah,
very
thank
much.
you.
And I
Thank
guess
you too.
to wrap it up for today, we would just be announcing another winner of the Terraform certification voucher. So, without any further ado, congratulations, Pavan. I see you being
Yeah,
very active in the chat as well. So,
yes, congratulations. That's very good.
reach out to Brad, and he'll be able to get the certification voucher sorted for you. And best of luck with the exam. So I think that's actually a wrap on our end. Hamid, do you have any closing remarks? Any thoughts?
No, thank you. Thank you, everyone. I hope this session would be useful for all of you, and I hope you liked it. Thank you all.
Thank you all. See you all next week.
Have a good day. Bye.
Bye.